Hello, everybody. My name is Tihomir. We have Charles here with us, and today we're going to talk about message-driven microservice orchestration with serverless workflow and AsyncAPI. So the table of contents is we're going to introduce the serverless workflow project. We're going to talk about a little bit about the project stats and our roadmap, and then we're going to dive into the integration with AsyncAPI and also show a demo that kind of puts it all together. So serverless workflow is an open source, vendor neutral, community-driven workflow ecosystem. And if you would interested to get started and learn about it, here's some URLs and links. Most important, just serverlessworkflow.io. You can go there and get all this information there as well. At its core, serverless workflow is a specification-based DSL, or domain-specific language. The DSL itself can be represented as markup, so both in JSON and YAML. And the idea is that as a specification, we define all the rules of the DSL as a JSON schema, so it can be validated and things like that. We also write tons of documentation about every single piece of functionality of the domain-specific language. And we also provide a lot of different examples. We also want to learn and compare ourselves to other technologies and other DSLs out there. So we have a bunch of different comparison documents. If you're interested, if you're coming from a different DSL or things like that, how it compares to serverless workflow. In the end, we are a CNCF project, currently sandbox, working for incubation status. And we have our communities based of people there, kind of knowledge experts in the workflow and the DSL areas as well. So every DSL out there has to conform to some sort of technology or fit in some sort of technology domain. And for serverless workflow, we are in the serverless tech domain, meaning that we really focus on things like defining events and also function invocation. So for events, we use the cloud event specification, and what you can do in the DSL is define things like how you want to consume events, how you want to do event correlation, produce events. We have some sort of event grouping if you want to specify some sort of unions or intersections of events that you want to consume or produce, and also provide reusability between different workflow definitions as well. As far as the functions event side or invocation of third-party services, basically, we use standards. So we use things like AsyncAPI, OpenAPI, GraphQL, and things like that, and really kind of focus on using the standards rather than providing some sort of proprietary ways of invoking services and functions, which is kind of typically the case in most of the DSLs that you walk around there. So as far as function invocation, with the serverless workflow DSL, you can define things like invoking, of course, third-party function sync or async, defining retries in case of some sort of failures. You have a way to use domain-specific language within the DSL, so you can name your functions the way that makes most sense to your applications. You can define things like timeouts. You can define error handling again, and again, retries. The DSL itself provides very powerful control flow logic. So it has some sort of core features, which are kind of, people are used to having those, or pretty much must-have type of control flow logic that's present in any sort of DSL or useful DSL, such as, defining a sequence of executions. So you can define your pipelines and stuff like that. Decision-making, which can be either data-based or event-based, things like that. You can define looping structures, retries, human decisions as well. With the DSL, you can define parallel and sequential executions. And of course, it has very powerful error handling features as well. On top of that, serverless workflow also provides a number of enhanced features. So for example, automatic retries, you can define that, your function invocation in case of errors, you want to automatically retry, given some sort of retry configurations that you provide through the DSL. You can hook in your secrets and constants and start using those for example, as values of some parameters they want to pass to function invocations. We have a very pluggable expression language. Every DSL out there that has to have some sort of expression language in order to make it fully executable, and we allow that to be pluggable. So by default we use JQ, but you can really plug in, as you will see in the demo, we're going to plug in JSON path, for example, and use that as well. The DSL itself supports defining both short and long-running workflows. And we have other features, for example, continue as feature, which allows you to continue your workflow execution at some point as a new execution or a new completely different type of workflow that needs to continue at some point in time. Compensation, we provide custom function types. So if, for example, even if you don't want to use some of the standards as we defined and have some sort of custom invocation of some sort of services, you can define that as well. Things like cron execution, sleeps, resource authentication, and a lot more. So check out the documentation, and you can really see, and then our examples showcase all of these features as well. On top of the DSL, we also provide some custom extensions. So these are some sort of extensions that you can enhance and use to enhance the workflow definitions. So two that we provide out of the box are key performance indicators extension. So you can use it to define and measure your improvements of workflow as far as performance and cost and all kinds of different things like that. Another extension that we provide is rate limiting. So you can actually define on top of the workflow definition, which invokes some services, whether that be synchronous or asynchronous or whichever way you define them, you can define rate limiting, for example, function invocation, concurrent function invocations per some sort of time and things like that. As far as the user of our project goes or the DSL, you can define your custom extensions as well. So this is not just limited to the what we provide. It's very, very pluggable. So we talked about that serverless workflow is an ecosystem. So we don't only provide our specification, but our project on top of that provides some usable things for the community and our ecosystem. So we provide a set of SDKs. We currently have it in Go, Java, .NET, and TypeScript. And these SDKs can help you, whether you're just like a developer or you're building a runtime for our DSL, provides things like parsing, validation, both schema and object type of validation that can be also extended to fit your needs. We provide a set of utility methods, especially if you're developing runtimes. There's a large set of utility methods that will really help you to deal with not having to deal with writing custom parsing logic or some sort of things like that. And we also provide diagram generation. So even though our DSL is not flowchart based or graphical, so it is defined again with JSON or YAML markups, we do provide visualization of your workflow definitions that you define in our DSL. In addition to that, we also host some runtimes in our projects. So we are open to hosting, if you have a runtime that implements the serverless workflow specification and would like to make it part of our project, you can contribute that. And we currently have Synapse, and Charles has contributed that to our specification, which is a Kubernetes native runtime. Now, of course, we support all the different runtimes equally, whether that be, you host it yourself somewhere in your companies or want to contribute it to a project. So that's equal, but there is, just an opportunity if you're willing to. We're more than happy to work with you on hosting and helping you with growing your runtime within our project as well. So in addition to that, we also provide web tooling support. Basically, we will look at this in the demo. So today, we do provide ways for you to develop and also visualize your workflow definitions using web-based tooling. And also we provide some IDE support, for example, VS Code and IntelliJ and things like that, where you also have some sort of plugins or extensions that help you get started and work with the serverless workflow specification. The most important thing, though, about our project is, of course, the community. Like I said, we are part of CNCF and also the Linux Foundation. We have been a project for, Sandbox for about a year, and this project has been around for longer than that. And the most important thing is our community. We all of us are individual contributors, and we're not backed by anybody right now. So everything that we do, all the help and community support and the whole ecosystem support that we provide is completely community driven and vendor neutral as well. So as far as adoption goes, this is kind of important, to know for every project. We do have some partner projects within CNCF that we're collaborating with, cloud events, AsyncAPI, of course, and things like Tremor and Argo as well. And we also have some open source collaborations with different companies that are interested in using our specification. The list is much bigger than that, but this is what currently we can show right now. So as far as different implementations goes, here are some, of course, implementations that have publicly exposed or allowed us to show, but there is many more that are currently in the works. So hopefully by next year, we will see this list grow a lot more. So as far as any sort of open source project that you encounter, you might want to know some sort of stats about it before you pick it up. So this is kind of like just a short list of things that we have done over the last year, and we have shown as a project continuous growth. We had a ton of different PRs. We had over 2,000 commits by over 30 different contributors from 10 plus different companies. So we are very diverse, and again, we are kind of involved in trying to help everybody that is interested in using the specification. We added 2 new project maintainers, and currently we have 5, all from different companies. So we really show diversity within the project as far as that goes. We added over the last year 2 new SDKs, so we added .NET and TypeScript. And we also released a lot, had a lot of different releases for our other SDKs. And of course, as mentioned, Charles here has contributed the Synapse, which is the Kubernetes native runtime that is hosted in our GitHub repositories as well. As far as the project roadmap goes, this is kind of like a year in review. We started off with kind of like, our release schedule and released version 05 in November last year. We had steady sort of releases throughout the last year. Currently, the current version of Serverless Workflow specification is V07, and we're planning to release 08 next month. As far as 1.0 goes, we're looking currently at April next year. But even now what we're doing is if you're picking the Serverless Workflow project up right now or thinking about using it would be version 07, the latest. And until 1.0, we will only do backwards compatible updates and features. So if you're thinking about starting to use our DSL, you can rest assured that until 1.0 there will be no breaking changes for you, so you can start using it right away. All right, so now to the cool part. AsyncAPI plays an integral role within serverless workflow, and basically, like we said, if you look at DSLs right now, probably most of them are going to have some proprietary ways of you having to define how you want to invoke some sort of function or services out there. Workflows itself are orchestrators, right? So your workflow, you define your control flow logic and deal with things like how when you want to invoke services, and then you have to deal with like some sort of data manipulations and things like that. That represent your orchestration effort. So what we do is, instead of defining some proprietary ways on how to invoke these services, we use AsyncAPI. We also have other ones, but AsyncAPI is definitely the one for event-driven microservice communication. So we use our specification basically relies on AsyncAPI definitions. So you can have one or more there that define some sort of services that you want to communicate with. And while we're executing our workflow, we define basically in the DSL, all you have to define, as we'll see, is the path to AsyncAPI definition, and you have to provide the operation ID. And with that, basically, our workflow DSL describes everything, what events have to be produced, and what type of channels and things like that. And all is defined with AsyncAPI rather than it being hard-coded or being proprietary inside the DSL itself. So the idea is that the serverless workflow definition utilizes the AsyncAPI to not only define how this functions or services have to be invoked, and then AsyncAPI provides all the information to the runtime that executes the workflow definition on how to do that actually. So as far as that goes, then the runtime has all the ability to know, for example, where to send the particular events. That can be, of course, go through all the different types of message brokers that AsyncAPI supports, but also you can, it supports WebSockets as well. So that really allows it for specification-based communication between your workflows or orchestration of your business logic with any type of service, and it's fully described via AsyncAPI. To look a little bit deeper into this, on the left-hand side, we see, for example, JSON-based workflow definition that is written in the serverless workflow DSL. And here in the little yellow box on top, we have a function definitions. These are, the definition that is reusable between multiple workflows and basically defines some sort of function to some sort of service that we might want to invoke during execution of a workflow. So we see here in our function definition that we have a domain-specific name, which is called invoke banking service. And each function definition has a type. In this case, type is AsyncAPI. So your runtime, when it wants to invoke this function, knows exactly that we're dealing with AsyncAPI definitions here. And then we have the third parameter called operation. And so this parameter defines the path or the URI to our AsyncAPI, definition. And just, and then the second part of the operation parameter value is the operation ID. So on the right-hand side, we see our banking YAML AsyncAPI definition. So what we see here, we have this channel on customer transaction 03 channel, and it has a published definition and with the same matching operation ID that we specify in our workflow definition. And that's it. The AsyncAPI definition really defines everything. What type of event has to be sent to what channel has to be sent, what should be its bindings basically, and what is the message and its format that needs to be sent in order to invoke this particular service. On the bottom of the left-hand side in the little green box, we actually see the control flow logic of our workflow definition. And we define a single state, and there's different states. Each state or task or step or whatever you might want to call it defines a piece of control flow logic. And in this case, we have an actual action, and this action references our function definition and can pass in some arguments. So at that point, we say, okay, we want to actually invoke this particular service. And the AsyncAPI definition defines everything that we need to know, or the runtime needs to know, in order to actually execute it. All right, so let's go to the cool part about the demo. Again, here's some links. If you're interested in our project, go ahead and hit us up on our website or Slack or Twitter and things like that. All right, so let's go ahead. So what we have done is our project is basically, we have, one second. our banking service. Our banking service is using the AsyncAPI definition that we've showed earlier. So this is the AsyncAPI definition of our banking service. It basically has a channel, is a publish operation with our send transaction operation ID, and it also has a subscribe channel that it can send results of the invocations events to this particular endpoint. Both of the bindings that we use are Kafka bindings. You know, we can use MQTT or whatever. And since we're running this locally, we have a server, which is a localhost port, and the protocol is Kafka. So we have Kafka running locally in our system. Now, what I've done is I've used the AsyncAPI code generators to actually generate this banking service Spring Boot project. So it's all Java-based in this demo. And I've used the tooling to actually generate the whole project. So just from this simple definition with the AsyncAPI tooling, you can generate the whole service. And what I've done only is in the generated message handler. This is the handler which actually, sorry, I'm making this bigger, receives the event that basically comes from our workflow orchestration. And we have also, after we receive the event, that we process it, and then according again to our AsyncAPI definition, we send it to our publish channel, the results as well. So that is the application itself. It's Spring, our service that we want to invoke. The second application that I have is actually a Quarkus application, and this is where our workflow, we define our workflow, and also it's able to execute it as well. In itself uses the our banking AsyncAPI definition, the same one that is also describes the service that we just created. And this is used by the workflow runtime. In this case, this is a temporal. Temporal is a resilient workflow runtime that we also, you know, provide some sort of support for, and is able to interpret the serverless workflow DSL, and is able then to from this definition, you know, be able to send and receive events from in this case our Kafka. So that's it. So let's go ahead and start these applications up and see how this works. So let's go ahead and start our service with, you know, it's a Spring Boot application. And let's go ahead and start our Quarkus applications, which is our demo, actually, the one where the hosts our workflow definition and the runtime, and it needs to communicate with our banking service. So once we've started that up, also I wanted to just show you, we have Zookeeper here running and a local Kafka instance running as well. And just to show here on the last tab that we're communicating via the Kafka broker, we have a consumer here on our customer account info 3, which is the channel that is defined in our AsyncAPI definition. So let's go ahead and open localhost 8080. Now this is our UI of our actual the Quarkus application, or the demo application. And here we see some of the serverless workflow project kind of utilities, or the ecosystem. On the left-hand side, we have our little web editor that you can use to, for example, define your workflows. And it has things like validation and also auto-completion as well, which is based on the serverless workflow JSON schema that defines the DSL. So you also have validation. So for example, if we removed one required parameter, we should see here, for example, missing property spec version, for example, and things like that. So if you're exposing this, for example, to your end users or customers to define their own workflows, you know, you have a lot of help there, you know, that helps them to write proper and valid workflows. On the right-hand side, we also have a workflow diagram generation. You can change or update your workflows here and click on the button to generate the diagram for the particular workflow that you're writing. So just real quick to go through the demo and the workflow that we're going to be using today. First of all, we're going to look at the function definitions. We do have, similar to what we shown in the slide, a single function defined, which is invoke banking service. It is async API type, and it has operation of banking.yaml, which during execution of our workflow is going to be parsed, and we're going to get the send transaction operation ID and then figure out how to or where to send our events to in order to trigger execution of our banking service. As far as the control flow logic go, we have the states block, and here we have a single state. It is of type for each. So we can pass basically one or more transactions as workflow input to our workflow. And for each one of the transactions performed by this particular customer, we're going to invoke our banking service as defined by the AsyncAPI definition and get the results back also. So let's go ahead and do that. So our workflow definition is not, is one thing, and we can execute it. But at the bottom of the page, as you can see, our workflow can have input. It is JSON, but we can also, of course, visualize that in the web as well. So here, what we can do in order to start the workflow, we can give it some input. So let's give it let's say a customer ID of 789, for example. And let's do some transactions. So let's say this user had a deposit of $100, and these are space separated. And for the case of the demo, you can do the UI better. So let's say we did a withdrawal of $50, and then we had, let's say, another deposit of $20. So these are type of the transactions that this user has done, and we want to process these transactions with the banking service. If we run the workflow, actually, we will start the workflow. The workflow is going to look at the async API definition. When it comes to actually execution of our banking service, it is going to send, the event on the appropriate topic of our for Kafka, and is going to communicate with the banking service through that. So let's go ahead and run the workflow. Our workflow results are on the right, and I'm going to expand that. So what we see as far as workflow execution goes, we have workflow results, and you can see them also here in our demo. 1 second. Yeah, so result is JSON, but we can also see them in the UI. We've seen that the customer ID is 789, which we specified. We see the transactions that have been entered here as well. And we see all the different functions that have been invoked. In this case, we invoke our banking service function here 3 times for each one of the inputs or the customer transactions that we have provided. And also, since our banking service produces a result back, so via event, we can see here that for this particular user, the current total or the total in their account right now after these transactions is $70, which is 50 plus 20, I guess in this case, that would be right. So let's take a look at also one more thing. So here we have, since we are running this on Temporal and its runtime, Temporal provides us with a web UI as well. And we can see here that we had one workflow that has been executed. It's serverless workflow customer transactions. It has a particular run ID. And we can see here that we have completed, during the demo, this workflow execution. Now, if we can also look at the history here, we can see the input, which is the DSL, and also we see here the results as well. And one thing that you can do here also with Temporal, but also other runtimes, probably as well, you can have a complete history of what has happened during the workflow execution. So we can see here that we have executed a number of what Temporal calls activities, or in our case would be the actual request for function execution and things like that. So you have full control with the runtime, and some sort of visualization and information that you can get using serverless workflow and as well. So that's it for the demo. I hope you guys enjoyed. Again, thank you very much on behalf of myself and Charles and the whole serverless workflow team. I would like to say thanks for having us here on the AsyncAPI Conf, and I hope you have a great day.